This is JEE 2020 paper 1 section 2. One or more than one correct options are given there. So let's start our video right after this short break. And if you are first time on my video, then please like, subscribe and don't forget to hit the bell icon button to get the video first.
Audio Jungle. Audio Jungle.
Question number 7 of section 2. This question is from modern physics. A particle of mass m moves in a circular orbit with potential energy Vr is equal to Fr, where F is the positive constant and R is the radius from the origin. Its energies are calculated using Bohr model. If the radius of the particle's orbit is denoted by capital R and its speed and energy are denoted by V and E respectively, then the nth orbit, for the nth orbit, here h is the Planck's constant. These options are given. First two options are depends on radius and velocity, and another that is total energy, you see, capital E. So what is the strategy here? Here too, for the circular orbit, as it is moving in circular orbit of mass m, so centripetal force is required. And this centripetal force can be evaluated here, F, that is centripetal force. And here that can be evaluated as the potential energy relation with force, that is F equal to minus du by dr. Means if you differentiate this potential energy, then you will get the force. So first of all, we will differentiate this potential energy and we get force and equate with centripetal force. And as you know that the angular momentum means mvr is equal to n into h upon 2 pi for this Bohr model. You apply this one. In this way we can get the relation between r and number of orbit and velocity and number of orbit. And then substituting these values of velocity, we get the total energy by adding kinetic energy and potential energy. Potential energy you can take from here, and kinetic energy, that is half of mv square. Use this v from that one, mvr is equal to n into h upon point. This will be the strategy. So let's start our solution. Let's see here. So Vr is equal to Fr given in the question. Now differentiate F equal to minus dV by dr. That will be differential of R, that is 1. So that is minus F. And here what is centripetal force, that is for this one, F equal to mv square by r. Substituting over here. And also we know that mvr is equal to n into h upon 2 pi. So from 1 and 2 you get the value of R. So capital R is equal to nh upon 2 pi mv. And now substitute this value of V over here as solve this V in terms of R. So what we say that is R is equal to nh upon 2 pi mv. Now substitute this capital R in equation 1. You will get mv square by R. For this R in denominator, that is nh upon 2 pi mv. Now solving this, what we say here, V cube is equal to nhf upon 2 pi m square. It means V is proportion to n to the power 1 by 3. So it's okay. In any one of the option is V is equal to n or 1 by 3 also the given. And capital R, as you know, that nh upon 2 pi mv. Now you submit over here, that is R equal to kn upon n to the power 1 by 3. So what we say here, n to the power 2 by 3, that is n to the power 1 minus 1 by 3, that is 2 by 3. That is means if you see here first and second option, then R is n proportion to n power 2 by 3 we got, and this one. So B option is correct among A and B. Now there is C and D. Check for total energy, that is kinetic energy plus potential energy. Kinetic energy is half of mv square, as you know, and potential energy, it is given in the question, Fr. So Fr you submit here, and half of mv square, that is half of Fr, as we have evaluated here. So half of mv square, and that is 3 by 2 of Fr, as you get the value of mv square from here, that is Fr. Just cross multiply from equation 1, mv square, that is Fr. So that is half of Fr plus Fr, that is 3 by 2 Fr on adding F, and what the R is nh upon 2 pi mv, and this is velocity. As velocity you have evaluated over here. So nfh upon 2 pi m square, and as power 3 to the power 1 by 3 you submit over here. And in this way you calculate the value of 3 by 2 n square h square f square upon 4 pi square m to the power 1 by 3. In this way, if you see here, C option is correct. Yes, C option is correct. So B and C are correct choices of question number 7. Now let's step for another question, that is question number 8. Question number 8. The filament of a light bulb has a surface area 64 millimeters square. The filament can be considered as a black body temperature of 25,000 Kelvin, emitting radiation like a point source when viewed from far. At night, the light bulb is observed from a distance of 100 meters. Assuming the pupil of the eyes of the observer to be a circular with radius 3 millimeter, then these options are given. Here the constants are there: Stephen Boltzmann constant, Wien's displacement constant, Planck's constants, and speed of light is given. So power radiated by the filament in the range of this means here you have to apply Stephen's law for this A and B option, as radiated power entering from one eye to the observer in the range of this one, and then you have to go for for the area of you can find the area for the eye surfaces there. That is something is given here, no? Pupils radius and this all given. So you see circular with radius, this one, pupil of the eye. Assume the pupil of the eyes of the observer to be a circular with radius 3 millimeters square. With the help of this area, you can use over here in B option. And in C, D option, that's the Wien's displacement law is given. Lambda m into T equal to constant. So this will be the strategy to solve this, as it is more than one correct option. So for first two, that is the Stephen's law, and another two that is in from Wien's law, Wien's displacement law. So let's start. You see, P is equal to small e sigma A T to the power 4. A is the area of cross section. Sigma, that is Boltzmann, this one Stephen's constant. As Stephen's constant is given over here, 5.67 into 10 power minus 8 watt per meter square Kelvin to the power minus 4. You just submit this value over here, and area, that is area is given here 64 millimeters square. So converted in meter, that is here that we say as this one is here in per meter square. Yes, you have to convert this in millimeter. So 25,000, that is Kelvin. Temperature is given 25,000 Kelvin. Directly you can use here. Now this is to the whole power 4, and 5.67, that is into 10 to the power minus 8, that is retaliated with this one. And finally the result will be, after calculation, you will find 141.75 watt. This radiated power entering one's eye, then you have to divide with 4 pi r square. This is means per area, and into area of the this one pupil of eye. So radius of pupil you have to consider over here. Now submit these values, and after calculation you will find that B option is correct, as 3.19 into 10 to the power minus 8 watt. 8 watt to 3.25 into 10 to the power minus 8. So here this one is correct. Means 318.9 is given over there. Means 3.19 into 10 to the power minus 8. So as it is lies between 3.15 and 3.25 range, so B option is correct. Now go for third and fourth option. So you need, that is Wien's displacement law, that is lambda m into T equal to constant, and capital T, as you know, that is capital T is here 25,000 Kelvin. You can use frequently over here. And lambda m into T means B, that is Wien's constant, is also given here in the question. 2.90 into 10 to the power minus 3. Then you can submit over here 2.93 into 10 to the power minus 6. You can convert it in 25,000 Kelvin, and submit and calculating, you will get lambda m is equal to 1160 nanometer. So that is lambda m 1160 nanometer is given. Yes, C option is correct. Now go for D option. If you check here for the number of protons per second, so that means n is equal to hc by lambda is equal to p. So capital N you can find, and submitting as h is Planck's constant. You know, here this is the Planck's constant is given. Planck's constant is 6.3 into 10 power minus 6.63 into 10 1 is 34 joule second. So submit this value. H and C is light velocity. Lambda here we have already calculated. This one lambda is given. So yes, and then P is Planck's constant. You submit this here, and for lambda, that is here given, taking the average wavelength of emitted to be 1740 nanometer. 1740 nanometer you just used here, 10 power minus 9 as nanometer. So after calculation, D option is correct. Okay, simple calculative type problems is there. Now come for class. So any of B, C, D options are correct. Now go for next question, question number 9. As this is question from dimensional analysis. It's a very easy question. Anyone can do here, but it's a very simple comparison, nothing else. Now let's start. Sometimes it is convenient to construct a system of units so that all quantities can be expressed in terms of one physical quantity. In such system, dimensions of different quantities are given in terms of quantity x as below. So positions, we have assumed that in the question, according to as per question, x to the power alpha speed can be as x power beta, acceleration x power p, and here linear momentum, that is x to the power q, and force, that is x to the power r. Now you have to find these relations between alpha and beta and gamma. Now simply you haven't to do anything. You just write down the dimensions of positions, write down the dimensions of velocity as position, that is L, and what is that is as velocity, that is L t power minus 1, L t power minus 2, linear momentum, that is M L t power minus 1, and just compare, and force, that is M L t power minus 2. And just submit this and compare, you'll get the relation between alpha, beta and gamma, nothing else, nothing to do over here. So here more than one correct options are there. So just only nothing you have to do, check this results. So as you know, x, that is here, first one is x to the power alpha, that is, it's nothing, it is the position. So position, that is here x, no, this one is position x. So x to the power alpha, that is p by v, means time. So x to the power alpha can be written as p by v time. V, that is velocity, x to the power beta, and acceleration, that it means x v upon a, means that is time. So that what we say here, and here that one is for p, that what we say, submit this value x to the power q, and f, that is position upon speed, you can say is speed upon acceleration for x to the power r p by f. Just compare these all. So x by, if you convert in p by p, v and a like this, then x to the power alpha upon x to the power beta here, and then x to the power beta upon x power p, x power q upon x power r, equated this. And now equating here, so alpha minus beta, you will get beta minus p, you will get q minus r. So in this way, alpha plus p is equal to 2 beta, and q plus p is equal to beta plus r, and p plus q minus r equal to beta. In this way, if you check here, then A and B options are correct. Okay, nothing to do over here. Question number 10. It is from electric field is given over here. A uniform electric field E minus 400 under root 3y Newton per coulomb is applied in the region. A charged particle of mass m carrying a positive charge q projected in this region with velocity 2 root 10 10 to the power 6 meter per second. This particle is aimed to hit a power target capital T. T target is here, diagram is given in the question, and which is 5 meter away, means the range is given over here, from its entry point in the field as shown schematically in the figure. Q by m, this one is 10 to the power 10 coulomb per kilogram. Okay, Q by m is given, the value of Q by m. So what do you have to do here? This is as charges check positive, yes, positive charge is there. So positive charge is there, so electric field and force will be acting, and some mass is also there of this particle charge. So due to this electric field, acceleration will act downwards. So as this is a analogous to projectile motion problem. In projectile motion, if you see, gravity is acting downwards. So instead of gravity, here gravity is replaced by this one, E by, you can say F equal to QE. And if you divide with M, then you will get the acceleration. So that is the acceleration over here, that is QE by M. So Q by M is given over here, and electric field is this one, and this is this negative sign shows y direction, means unit vector y. Negative sign shows that is in negative y direction. So it's nothing to do over here. It's just like a projectile motion problem. It's quite easy. So this is our strategy. Let's start. So if you see here, the range is given in the 5 meter, and initial velocity according to as per problem to under root 10 into 10 to the power 6 meter per second, and here electric field is going downwards. Simply you just use this formula as in projectile motion we use T equal to 2u sin theta by g, r equal to u square sin 2 theta by g. Instead of g you have to replace with acceleration, and acceleration is QE by m, and submit the values required data. Q by m, as you know, here Q by m is 10 to the power 10 means what you just submit the g over that 10, here you have to replace with that 10, here 10 to the power 10, and nothing to do over here, and range that is 5. So in this way we get sine 2 theta. So sine 2 theta, here we after calculation we get root 3 by 2. This shows that 2 theta is 60 degree or 120 degree, so theta is 30 or 60 degree for some range. And then for time of flight you have to find, so T equal to 2u sin theta by g. So if you check here, theta angle which was required over there, and here time of flight is also required. So time of flight as it is required, so this one T equal to u sin theta by g, submitting these values of theta one by one, you will get this one for some range or same range. So that is T equal to 2u sin theta by g, right? And submit, you get the value of time of flight. So check the options. So if you see over here, this one 30 degree and 60 degree due to this one B option is correct, and time of flight was there root 5 by 6, and this one root 5 by 2 microseconds. So this one C option is correct, as you see this one. Now come for question number 11. Shown in the figure here, in semiconductor metallic strips has a thickness T and resistivity rho. Its linear radius is R1 and outer radius is R2. If a voltage V0 is applied between its two ends, a current I flows in it. In the radiation, it is observed that the transverse voltage del V develops between its inner and outer surfaces due to purely kinetic effects of the moving electrons. Ignore the role of magnetic field due to the current. Okay, then figure is schematic and not drawn to scale. Options are given. I current you have to find in this one, and then after what you have to do here means A, B, C. More than one correct options are there. Yes. So for here, that is means the outer surface is higher voltage than inner surface. The outer surface is at lower voltage than the inner surface, and delta V is proportional to I square. You have to submit these results. So let's go ahead. Here, this is simply what you have to do. First of all, as R1 and R2 are the resistors. So here, so from R1 to R2, you have to. It's a varying resistor is varying here. So you just if you see here that these resistors are, if you consider the elements here in this one in shape of arc. So these elements are increasing here from R1 to R2, and they are in parallel order. So for the elemental strips, if you consider here from this to here, this strip when you consider in arc shape, in semicircular arc shape, so that you have to find means these elemental strips are in parallel order. So you have to calculate this R as 1 by R as the in register the in parallel order. The equivalent resistor is can be calculated by 1 by capital R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And the analogous pattern, if you go ahead, so 1 by R is equal to means integral of 1 upon dr. So dr strips you can find that one, and then you just integrate this all, right, from R1 to R2. So let for this one, and once you get the resistor here, you can get the find current also di, and for this I, as here this one is the resistivity is there, so you can go ahead NEAVD, the I is equal to NEAVD, and with drift velocity you can evaluate here, and with this electric field is also there, so you can find delta del V. So let's start and check the solutions over here. So what do you find here? First of all, to calculate the resistance, this one L, that is pi r, right? Here the entire length is L, that is pi r. So dr is equal to rho pi r upon tdr. Okay, but all the elemental steps are in parallel. So as I told over here, 1 by r equivalent is equal to 1 by r integral. You have to do 1 by r equivalent can be go ahead, r1 to r2 t dr upon rho pi r. As you know, r is equal to rho into L by A, means L over here, that is length is over that, that is area. Length, that is, instead of length what we have written, pi r is this length, periphery of this semicircle. So half of the circumference we have considered over here, that is length pi r. So now if you integrate this integral of dx upon x, that is ln x. So the integral of dr by r, t upon pi r, you can take out this one over here, and so that what we say here, ln r. So upper limit, lower limit, ln r2 by r1. So in this way we get the I also. I is equal to, that is v0 upon r equivalent, and r equivalent make it the reciprocal over here. So that we say ln of r2 by r1 v0 t upon pi rho. So if you see, option A is correct. Yes, option A is correct. Now come for option B and C and D. Now for check for B and C and D, if you see here, the electrons, the movement of electrons, the pattern, as current is moving over here, so electron is moving from this node to this node. So electrons moves in circular path so that they experience centripetal force due to this electric field. Here the electric field is there. So on electric field here, force will be acting over there. So F equal to EE, but in opposite direction here. So the centripetal force, this one will be required and towards the center over here. So what we see here, to check potential drop across the surface, let's consider external resistance dr is equal to rho pi r tdr. So what we say here, di is equal to v0 tdr upon rho pi r, and hence we say NEAVD. You can use just di, I is equal to NEAVD. So di is equal to NEA drift velocity v0 tdr upon rho pi r, as A is equal to, that is tdr for this one strip, this one area. So Vd you can find kV0 upon r. So in this situation what we see here, that is now as the electron moves in circular path, so E is equal to mv square by r. This Vd you have to find. Let's see. So electric field, as we can evaluate over here, so dividing with this E, that is, you say m upon ER k square v0 square by r square. In this way we can find the electric field, that is k dash v0 square upon r cube. Therefore potential drop, that is del V is equal to minus integral of E dot dr. Now you use this E expression and integrate over here dr by r cube. So 1 by r cube, that is r to power minus 3, integral is r to power minus 3 plus 1, that is r to power minus 2, that is r square. So here what we say here, that is r square, that is r square upon r1, 1 by r1 square minus 1 upon r2 square, and that is del V is equal to k double dash del V naught square. So del V is proportion to V naught square and del V is proportion to I square. So that's why if you see over here, then these options are correct. Del V is proportion to I square. So D option is correct. But here also you see among B and C, the outer surface is at lower voltage than the inner surface, and the outer surface is a higher. So outer surface will be the lower voltage from the inner surface, as due to centripetal force, electrons are towards the inner surface. So what we say here, the outer surface is at lower voltage and then the inner surface. So finally what we conclude over here, that is C option is correct. Okay. So let's go ahead for another problem. As shown schematically in the figure, two vessels contains water solutions at temperature capital T of potassium permanganate KMnO4 of different concentration N1 and N2 molecules per unit volume. Del N equal to N1 minus N2 is very less than N1. and hence what we see here, that is condition is given N1 is greater than L2. Okay, molecules per unit volume del N, N1 minus N2 is very very less than N1. So when they are connected to a tube of a small length, here in the diagram it is given small L, okay, and the cross section area S, this one is S, KMnO4 starts to diffuse from left to right, okay, vessel. Therefore, the tube consider the collection of the molecules behave as a dilute ideal gases, and the difference in their partial pressure is two vessels causing the diffusion. The speed v of the molecules is limited by viscous force beta v on each molecule, where beta is a constant, neglecting all the terms in the delta n square, which are in this. What we have to do here, we have to consider the first of all we have to find force. Force is equal to means change in pressure, and means pressure, what we say, force per unit area. So pressure can be related, force can be related as delta P into A. So what we see, P is equal to del P into S, del P into S. And for this one here, we have to apply P1 minus P2 into S. So P is equal to, what do you have to say, N1 and N2 is given. N1 minus N2, it is given here, del N. N1 minus N2, that is del N. And that is equal to KATS. Let's start. Here the two surfaces are there. This one is P1S and P2S. Let S be the area of cross section. So F equal to delta P into S. Delta P, that is P1 minus P2S. So P, you can submit this value as P is PV is equal to nRT. So let's say this is K constant, and small n is the number of molecules per unit volume, and capital N is the total number of particles. So that what we say, P is equal to N by V KT, and let's say this is small n KBT, and here that is N1 KBTS and N2 KBTS. So take out common over here, that is N1 minus N2 KBTS delta N KBTS. So if you see here, option A is correct, delta N KBTS is given here. And now for another options, that what we say, this one for B option, if you see, then this one delta N KBTS, this one, and here beta V is equal into N1 SL is equal to delta N KB into TS. So in this way you can find this one, delta N1 B beta VL is equal to delta N KBT. So in option B, force balanced is N1 beta VL and delta N KBT, and so this is also correct. And if you see the C option, that is S into delta this one dN by dt, that is SV N1, and S into submit these values here, you get. So from B option you can submit these values here, you will get beta into L. So correct option is C. So in this way C option is also correct. And for D, the rate of molecules getting transferred through the tube does not change with time. That's wrong. ABC option is correct. Okay, thanks for watching. Thank you.